Alright, thanks for watching, and today we'll cover a topic we can all relate to called related rates. And essentially what this answers is the question, how does one quantity change when another one changes? And we'll see the trick to this is all our differentiation rules that we've learned so far, which gives us a very nice application of derivatives in real life. And today we'll do a very easy but standard related rates problem so you can see how those problems work. And so here's the statement. Suppose the height of a triangle is increasing at the rate of 1 centimeter per minute, while the area is increasing by 2 square centimeters per minute. At what rate is the base changing when the area is 100 square centimeters and the height is 10 centimeters? So you see there's already a lot of info thrown at you, and our goal is to dissect all the information that's given. And for this, a very useful thing to do in related rates is to draw a picture. So let's draw a picture of a triangle here. So step 1, draw a picture. And I know you're very tempted to put numbers in your pictures, but don't do that yet. Okay? It's best first to write everything in terms of variables. So here, the base of the triangle is b and the height is h. So do not plug in 10 yet. We'll do that later. Then the next step is we want to figure out what we're trying to solve. Here the question says, figure out at which rate the base is changing. So what we want to find dB over dt when, let's see, I believe the area was 100 and the height is 10. Okay, good. Then the next step is to figure out some kind of equation that relates all of variables. So here what we would like is some equation that relates the area of the triangle with b and h. And this is sometimes a hard step. Here it's easy because you just use the formula for the area of a triangle. So A is 1/2 b times h. And then the next step is to differentiate. So dA over dt, it's 1/2 times the derivative of this. Because it's the product of two functions, we'll use the product rule or the Prada rule. And it's very important to understand everything is a function of t. So it's 1/2 dB over dt times h plus, if you want, 1/2 b times dh over dt. And now what we would like to do, we would like to plug in all the information that's given to us. So let's see, and that's why let's go back to the problem and see what we have. So we know a couple of things. We know how much the height is changing. So we know dh over dt, it's 1 centimeter per minute. We also know how much the area is changing. dA over dt is 2 square centimeters per minute. We also know the area is 100 square centimeters and the height is 10 centimeters. Okay, a lot of info, but that helps us plug stuff in. So as I said, we know that dA over dt, that's 2. And then 1/2, the stuff that we want to find, dB over dt. The height, which I believe was 10, and then plus 1/2 b, and then I believe dh over dt was 1. Or was it 2? Let me check. The height is increasing by 1 here. Okay, And then we can simplify that. So 2, it's 10 over 2, which is 5 dB over dt plus b over 2. Which actually means we can solve for b provided, we can solve for dB over dt provided that we know what b is. So the next step is to figure out what b is. And for this, now it's useful to draw a picture with all your variables plugged in. So this is very standard in related rates. It seems that you're doing your work twice, but it is pretty useful. Because now, what do we know? Now we know that the height is 10 and the base is b. And also remember, we know that the area is 100. So area is 100. So 1/2 BH is 100. But now H is, I believe, 10. So 1/2 B times 10 is 100. And last but not least, what we get, I believe 5B, it's 100. So B is 20. Ta-da! We found B, and last but not least, we can just plug into this formula. So 2, let me just rewrite this. 2 equals 5 dB over dt plus b over 2. That implies 2 equals 5 dB over dt plus 20 over 2. So 2 equals 5 dB over dt plus 10, which really means 5. Interesting, dB over dt reminds me of Dragon Ball. So dB, so 5 dB over dt, it's minus 8, and therefore dB over dt, it's minus 8/5. So what is our answer? So B is decreasing by 8/5 centimeters per minute, I believe. I think that was our unit. Yes. And therefore we finally found the answer to our question. And again, I want to say this is super typical in related rates questions. First, draw a picture of your situation, then find a formula relating your variables, and then just use some calculus, and at some point also draw the picture again. We'll see. If you think about this, every related rates problem will be this way, except the picture might be more complicated, or the formula might be more complicated. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.